welcome. As you are coming in, just begin to say hi. Okay, like, share, subscribe. Let's see the question we have here. We have a trolley of mass 50 kg is pulled from rest. Okay, underline these are from rest in a straight line along along horizontal paths by means of a horizontal rope attached to its front end. The trolley accelerates at a constant rate, and after 2 seconds, its speed is 1 meter per second. As it moves, the trolley experiences a resistance of motion of magnitude 20 Newton. Find A, the acceleration of the trolley, B, the tension in the rope. Okay, so that's what we have. The first thing we have to note here is a trolley of mass 50 kg is pulled from rest. So from rest means the initial velocity will be 0 meter per second. Okay, we also have at a constant accelerate at a constant rate, and after 2 seconds, t is 2 seconds. Okay, and velocity final velocity is 1 meter per second. First, find the acceleration of the trolley. Acceleration is unknown, that's question mark. Okay, then with the given parameters, look for the kinematic equations that connect the 4 given parameters. Okay, out of the 4 parameters, 1 is unknown. Okay, let's check this one. VU plus AT. Okay, so we know the final velocity is 1, the initial is 0. Okay, the acceleration is what we are looking for. The time is what? 2 seconds. Okay, so from there we can get this is 1 equal to 2. A is equal to 1 over 2, which is 0.5 meter per second square. So that's that on the first part. Find the acceleration of the trolley. Let's make the trolley to be this. This is a trolley. Okay. Along a straighter path. This is a path. Okay. Then we are told that the trolley is pulled from rest in a straighter line along a straighter path by means of horizontal rope attached to its front end. There's a rope here attached to the what? To the front end. Okay, and then the tension in the rope is this. Okay, as it moves, the trolley experiences a resistance of motion of magnitude 20 Newton. Okay, so this is the resistance which opposes the motion, and the value is what? 20 Newton. Forces on the horizontal equal to what? MA, and that's the tension minus the resistance force equal to the mass is 50, the acceleration is 0.5. So we have T equal to what? 20 plus 25. 50 times that 0.5, that's 25, and that gives us that 45 Newton. Okay, so that's that on that question. Okay, begin to share the links of this video across your different platforms. Coming in and begin to share the links of this video across your different platforms. If you are new on this channel, please subscribe to the channel. Okay, let's see this question. A lift of mass 500 kg is lowered or raised by means of a metal cable attached to its top. The lift contains passengers whose total mass is 200 kg. The lift starts from rest and accelerates at a constant rate, reaching a speed of 3 meters per second after moving a distance of 5 meters. Find A, the acceleration of the lift, B, the tension in the cable of the lift is moving vertically downward. C, the tension in the cable if the lift is moving vertically upward. So that's what we have in this question. So the total mass is 300 kg. This one is 300 kg. Okay. So that's what we have. The first thing we are going to do is to get the parameters of the question. Get the parameter of the question. We have a mass, a lift of mass 500 kg. That's the mass of the lift. And the lift contains passengers whose total mass is what? That's 300 kg. So we can have the picture of the lift. Okay, the mass of the lift is 300 and the passenger inside the lift is 300. The mass of the lift is 500. So if you add it together, that will be 800 kg. That's the mass. Okay, 800 kg. Okay, and we are told is lowered or raised by means of a metal cable attached to its top. So we have a metal cable attached to its top. So we have a cable, let me that with tension attached to the top. Okay, the lift starts from rest. That's a U, initial velocity is 0, and accelerates at a constant rate, reaching a speed of 3 meters per second. So the final velocity is 3 meters per second. Okay, and it covers a distance of 5 meters. Okay, what again we have there? Find the acceleration. We don't know the acceleration. That's a question mark. Find the acceleration. And then what again? We have the final velocity. We have the initial velocity. So we can connect this parameter together to check the kinematic equation. Which one contains this? You can check this one. V squared equal to U squared plus 2AX. We have the V. We have U. Okay. We have acceleration. We have the distance. Okay, we have the distance, but acceleration we don't know. That's what we are looking for. Begin to make a imputation. Begin to make a plug in those values. Substitute those given parameters. V is 3 squared. U is 0 plus 2 times acceleration, and then times 5, and that will give us we're going to have 9 equal to 10A. So acceleration is what? 9 over 10. And that's 0.9 meter per second squared. That's the acceleration for that question. Okay. So then let's go to the B part. The tension in the cable, if the lift is moving vertically upward. Okay. If the lift is moving vertically upward, then the weight of that lift, the weight will be going down. Okay, the weight will be going down. Okay, weight will be down. Weight will be acting downward. Okay, so in that case now, the acceleration is upward. Based on that question, the tension in the cable of the lift, the tension vertically downward. In that case now, this is the weight. If it's moving vertically downward, that means acceleration is what? The acceleration is vertically down. Acceleration is in direction of the weight. Okay, acceleration is in direction of the weight. And one thing you have to note when you are inside a lift, okay, when you are inside the lift, as you are standing, two things is happening on you. The reactions of the floor of the lift is acting upward, while your weight is acting downward due to gravity. Okay, the reactions of the platform you are standing in the lift is acting upward, while your weight is acting downward. So in this case now, the passenger is flowing in the direction of the weight. Okay, don't forget that your weight will be acting downward. You can see a little mass figure. Okay, it's lower raised by. So that's what we have there. So in that case now, the acceleration in this case is down. The lift is moving down. So that means the weight minus the tension, which is acting against gravity, okay, equal to what? Equal to ma. So that's the summation of the force. That's the summation of the force. Okay, you have your mass is 800 times 800 times 9.8 minus t equal to ma. That's 800 a. Okay, 800 a. That's that times 0.9. Okay, you can make the tension the subject, and that will be equal to move it to the other side. That will be 800 times 9.8 minus 800 times 0.9. So if you do that, you get your tension. Okay, if you do that, you get your tension. You can punch your calculator and get the answer for that B part. Okay, that will give you 8560. That will be 8560 if you punch your calculator Newton. So that's that on the B part. I'm going to recap this. I'm going to recap it again. Then we'll now go to the C part. Okay. The first thing we do is for us to look at the parameter. The lift contains passengers, and the lift by itself, it has a weight, a mass of 500 kg, and the passenger is what? 300 kg. So the total mass for the lift will now become 800. Okay, and the lift starts from rest. That's a U is 0, and then at a constant rate and accelerate at a constant rate, reaching a speed of 3 meters per second. That's a V, after moving a distance of 5 meters. That's a distance. Acceleration is not known. Use this equation. D squared equal to U squared plus 2AX, and then find your acceleration, which we got as what? At 0.9 meter per second squared. So the A part is done. Then the B part, find the tension of the cable of the lift. Okay, it's moving vertically down. Okay, and I've said when you are inside the lift, okay, two things is you need to note your weight. Okay, your weight will be acting downward, and then the reactions of the platform you are standing inside the lift, the reaction of the floor of the lift is acting upward. Okay, so that the two forces, okay, the weight is acting downward, and then the reaction of that platform acting on you is acting upward. So, but in this case, the tension of the cord, we have it here, which is what? We have the statement here that we are told here that a metal cable attached to a top, that's the metal cable. Okay, and we are talking of metal cable, there will be tension in the what? In the cord attached to a top. Okay, and then you must know that the weight we act downward, and we are told that the case we have here is that the lift is moving downward. It's moving downward. That means acceleration is flowing in the direction of what? Of the weight. If it's moving downward, acceleration is downward in that case. So then you find the summation of the forces, which will be the direction the lift is moving, mg, minus the one that opposes the direction of the movement, that minus what? Minus t, equal to what? Ma. Okay, then you make your substitutions and make c the subjects. For the c part, the tension in the cable, if the lift is moving vertically upward, in this case now, acceleration is now moving up. The lift is moving vertically upward. That means acceleration for the C part is upward. Okay, that means everything is moving upward. So that in that case now, it's going to be tension T minus what? Mg equal to what? Equal to Ma. You will resolve it along what? Along the flow of movement. The flow of movement in this case is vertically upward, and that means acceleration is what? Is upward. Okay, so that will be T, that will be plus T. The one that is down, that will be what? Minus the Mg equal to what? Equal to Ma. Okay, summation of the forces. You resolve the forces, okay, vertically. Okay, the resultant force is what? Is T minus Mg equal to Ma. So make T the subject, and that will be Ma plus what? Plus Mg. And that will be equal to, my mass is what? 800. My acceleration is 0.9. Okay, then plus 800 times 9.8. So punch your calculator and get the tension when the lift is moving upward. When the lift is moving upward. Okay, so if you punch your calculator, you're going to have 7,120 Newton. That is the tension when the lift is moving upward. I want to recap again. You need to know the direction of the movements. Okay, so when direction is vertically upward, it means that acceleration is upward, and you're going to resolve it. Okay, you get the resultant of the forces equal to what? Equal to Ma. Okay, that's just that. And you can use xy coordinates. You can use these coordinates plus y minus y. So if it's moving in this direction, the force in that place will be positive. The one that is against it will be negative. So combine them together, and that's the resultant force equal to Ma. So that's just that on this case. Questions still continue. If you're just coming in, please type, say something. You can mention your name. You can mention the location where you are watching from. Mention the location. Mention your name. Say I, and begin to what? Share the links, and most importantly, subscribe. Subscribe to the channel so that you can. This is the question we have. This is going to be quiz. Please put the answer in the comment section. Let's see your answer in the comment. Answer in the comment section. Okay. For the quiz, we have Albert and Bella. Albert and Bella are both standing in the lift. The mass of the lift is 250 kg. As the lift moves upwards with constant acceleration, the floor of the lift exerts forces of magnitude 675 Newton and 452 Newton, respectively, on Albert and Bella. The tension in the cable which is pulling the lift upward is 3,955 Newton. A, find the acceleration of the lift. B, find the mass of Albert. C, find the mass of Bella. Okay, either Bella or Bella, anyone. Okay, so that's the question. We want your answer. Put forward your answer in the comment section. You can begin to do that right now. Okay, let's know what is your response. What's your answer for this question? Question still continue, but this is for you. Put your answer in the comment section. And as you're doing that, begin to say I. You can mention the location where you are watching from. Okay, like, share, and subscribe. Like, share, and subscribe. And I want to say, don't be the only one watching. Call your classmates now. Call your classmates, your friends, your colleagues on different cultures, and begin to share the links of this video across your different platform. Like, share, and subscribe. So this question is for you. Begin to send the solution, the answers to the comment section. Questions still continue. This question is for you. Okay, this is a quiz question. Put the answer in the comment section. Okay, and let's look at the question again. Albert and Bila are both standing in a lift. The mass of the lift is 250 kg. As the lift moves upward with constant acceleration, the floor of the lift exerts forces of magnitudes 675 Newton and 452 Newton, respectively, on Albert and Bila. The tension in the cable, which is pulling the lift upward, is 3,955 Newton. Find the acceleration of the lift, that is A part. The B part, find the mass of Albert. C, find the mass of Bila. So that's the question. Begin to, let's see the answer in the comment section. Put the answer in the comment section. Okay, let's begin to do that right now. As you're watching me, this is not a movie. Take your writing material, your pen, your journal, and begin to follow along with me. Okay, I want to say you are in the right place. If you are yet to subscribe, do so right now. Begin to share the links across your different platforms, Facebook, on Twitter, on WhatsApp. Begin to do that right now. Thank you for doing that. Question still continue. Okay, question still continue. Next question. But before that, let's see the comment section and respond to those comments. Thank you for staying by. Thank you for staying by. And I will encourage you to stay to the end of this episode. Okay, so that's what we have. And I want to tell you, when you are finding the sum of the forces in the horizontal, in the x direction, and the y direction, let's have a little introduction. You need to be aware of these cardinal points before we go to the trigonometric functions. Okay, let me do it this way. You need to be aware of these cases. We are going to take into consideration the direction of plus y. Anything on vertical will take a plus, will be positive. Anything that is downward will be considered as what? Negative. This is vertically upward. Vertically downward will be considered negative. Also, along the horizontal, on these plus x, anything that finds itself on the horizontal, on the plus x, will be positive. Anything that finds itself on the negative x-axis will be negative. That is the first thing you need to take into consideration, because this is a vector and direction is very important. Plus, minus signify direction, and it's very crucial. Okay, when you are resolving forces along the horizontal or vertical. Then another thing you need to know, that will take us to what we call the trig functions. Okay, if you have your angle, this is theta. Okay, you have your angle. You can resolve. Let's say this is your force. This is your force F. We can resolve this force along the vertical, And at the same time, we can resolve this force along the horizontal. What are we going to do? We are going to use what we call trig functions. Okay, we're going to use SOHCAHTOA. I don't know whether you are aware of that, but that's very simple. If you are resolving along the vertical, we're going to use sine of the angle, which is the SOHCAHTOA. This is sin equal to what? Opposite over hypotenuse. Sin of the angle equal to opposite over hypotenuse. Okay, so let's do that. This is the vertical. Okay, sine theta equal to what? Opposite, I don't know. The hypotenuse is the f, is a vector f. Make the opposite as the subject. So the opposite will be equal to what? F sine theta. So for the vertical, this will be f sine theta. When you resolve along the vertical, it's going to give you f sine theta. Okay? When you resolve along the horizontal, we are going to use CA. That's the cosine of the angle. A is the adjacent. H is the hypotenuse. Okay? My adjacent in this case, I don't know. It's unknown. That's cos theta equal to adjacent. My hypotenuse is a vector f. Make adjacent as the subject, and that will be what? F cos theta. So when you resolve along the horizontal, you have cosine of the vector or of the force. When you resolve along the vertical, you're going to have sine theta of the what? Of the force or of the vector. Okay, sine theta, okay, times the vector or the force on the vertical, cos theta times the vector or the force along the horizontal. Okay, so that's that on resolving vertical horizontal. At the same time, it's also possible, let me claim this one, it's possible to have another angle here. Let's look at that. Let's say we have theta 2 in this place, theta 2, and the force here is F2. Let's do that. So for this place, it's going to be when you resolve along the horizontal for theta 2 for F2 along the horizontal, it's going to be F2 cos theta 2. This place is what? F2 cos theta 2. When you resolve along the vertical, it's going to be what? F2 sine what? Sine theta 2. Along the vertical, that's what? F2 sine theta 2. Then we can now find the total forces along the horizontal, total forces along the vertical. Okay, so summation of the forces along the horizontal. Summation of the forces along the horizontal. We have this one. That will be F cos theta. This place is positive. That's a plus x. But this place is on the negative x-axis. So it's going to be what? Minus what? F2 cos theta 2. Okay? Let's see summation of the forces along the vertical. Summation of the forces along the vertical. This is the plus y direction. So it's going to be F sine theta. This one also is also upward, plus y direction. That will be what? Plus also F2 sine theta 2. That is just the tip of resolving your forces, or your vector along the horizontal or vertical. Okay, I want to say at this moment, if you're watching me for the first time, please subscribe right now. Begin to share the links across different platforms. Begin to do it now. Call your friends to join us. This is very important. Okay? Some of my students pay for this heavily. They pay for this, but it's coming to you free of charge. What you can do for me to compensate my effort is begin to share the links of this video across your different platforms. Subscribe, okay, share, and begin to like. Okay, you find it beneficiary, like the video, share the video, and begin to share across the different platforms. And if you need me, you need my service, okay, one-on-one or in form of group discussion, group tutoring, group coaching, or executive coaching, you can send. I'll put my email in the description. I'll also put my email in the comment section. You can send me an email, then we can book schedule and we can meet via Zoom, Google Meet, and so on and so forth. Okay, and that will be tailored to your course. Okay, please begin to share now. Begin to share, like, share, subscribe. If you are yet to subscribe, please do so right now. That is one of the ways to support this channel. That is one of the ways to appreciate the energy. That is one of the ways to appreciate talking. Okay, talking is not easy. Begin to share the links of this video across your different platforms. Okay, let's now go to the solution of this one. Okay, I'm going to solve one. Okay, tonight, and then by the special grace of God, we'll continue tomorrow and we'll continue solving. Okay, let's check the comment section and respond to that. Then we'll continue. Call someone. Begin to say I as you are coming in. Begin to say I as you are coming in. Begin to say I as you are coming in. Okay. Begin to say I as you are coming in. Yeah, for the first one, summation of the forces on the horizontal. That's the first one we are told to do. Here, it will be what? Here, let me sketch it here again. We have a 60. We have the force 5 Newton here. This is x-axis. We have here 6 Newton. This place. So this will be equal to what? 5 sine 60. This will be 5 cos 60. And this place will be minus 6. So for the forces on the horizontal, it's going to be what? 5 cos 60 and then minus 6. So that's the answer for that. And then we can use mathematics cos 60. Cos 60 is half. Is 5 times 1 over 2. Cos 60 is adjacent over hypotenuse. That's 1 over 2, 1 over 2, 1 over 2, and then minus 6. So that's 2.5 minus 6. Okay, that's the summation of the forces along the horizontal, and that will give us what? 3.5. 3.5, yeah, 3.5 minus so that's summation of the forces on the horizontal. Okay. Then the summation of forces on the vertical will be equal to on the vertical we're having 5 sine 60, and there is no one again on the battery on the. We only have this one. Don't have another one again, and that will be equal to what? 5 times. Sin 60 is what? Sin 60 is opposite over hypotenuse. That's 3 over 2. Okay, that's 2.5 root 3 Newton. Okay, so that's that on that case. We'll continue tomorrow. God willingly, we'll continue tomorrow. Okay, if you're yet to subscribe, please do so right now. Share the links. Okay, like, share, and subscribe. I want to appreciate those that comes online, those that watch to the end of this section. Okay, I want to appreciate also those that doesn't stay long. Thank you, everybody. And don't forget my regular viewers for always coming on board. I want to say kudos to you. Thank you, thank you, thank you, thank you. Kudos to you for always coming on board. Thank you, everybody. Those that are yet to subscribe, begin to do that right now. Thank you once again. Thank you once again. See you tomorrow by the grace of God. Bye for now.